Hello and welcome to C2 Part 3, working in the RS-232 Manager. The RS-232 Database Manager manages the RS-232 command protocols by allowing codes to be added, edited, deleted, and entire new code sets generated. In this course, you will learn how to test codes through the database using the KDMC2500, as well as how to write commands using ASCII, decimal, or hex language, and how to create your own RS-232 database for local storage. The RS-232 Manager software is one of 5 components of the Key Digital Compass Control software suite. The icon is the first bottom third there is a DB9 RS-232 connector with the top 2/3, if you will, the Compass Control icon. Double-clicking the RS-232 Manager and then allowing proper access. Again, probably a Windows issue depending on what software you're working with, if you will or will not receive this message. But if you do, if you're running the software, you go ahead and grant proper access. Opening the RS-232 Manager brings us into the whatever the last library was that you had open. For example, here I do have Wolf Vision document cameras open. They are a fantastic manufacturer of visualizers and a Compass Alliance partner product. Taking a look in the device properties workspace here, we have the classifications of your devices, and this is going to be especially handy in the RS-232 Manager, where we saw how it could make things somewhat convenient in the IR Manager software in C2 Part 2. You could classify products as a switcher and specify the number of inputs and outputs that the device has. Moving to the right here, we have control properties. This is your RS-232 protocol, if you will. For example, by selecting the VZ9 Plus, my baud rate has adjusted to 115,200 for the baud rate. Parity, none. Stop bits 1. Bits 8. Flow control, okay, handshaking, these sorts of things here are all adjustable depending on the device, and you could set those up. The repeat settings are going to be similar to your IR Manager in C2 Part 2, where we discussed with you that this is always repeat is available here in the respective manager. However, your repeat while holding settings, although will be very useful in the future, are not an available part of the IR, RS-232, or IP managers, respectively, currently. Okay. But you will be able to implement that in the future, for example, when doing your volume ramping. Otherwise, right now, it is manipulated and implemented through the Compass Navigator software. When we hop to the right here, we have our MC ports for testing. That's your MC master controller. Now again, in the future, the MC drop-down here will enable detection of all master controllers in the network. However, currently that is not available. As you see, it has not detected any of the master controllers, although I do, of course, have one KDMC2500 connected, and that MC2500 is configured to an IP address of 40.192.168.140, so we make sure to match it here. And then we can choose our port that we'd like to do our testing through, whether it be the RS-232 main, which is the DB9 connection on the rear of the MC2500 chassis, or any of the multifunction ports, of course, being configured as RS-232. Now here we are able to connect and disconnect. By default, we are connected to our MC2500 with the appropriate settings. And we could change modes here from terminal mode to command mode. Now, terminal mode is actually used in the window below here, which is the KD terminal, which is essentially hyperterminal, if you will, or what you may be familiar with as hyperterminal, built in to the RS-232 Manager software. And command mode is where we would test any of our commands through the wiring connected to the desired device to be controlled. working across the bottom here, you have the clone output 1 button that really works in the case of a multi-zone unit device such as a matrix switcher or multi-zone audio system, amplifier, etc. Show the standard. By selecting or deselecting show standard, actually this categorizes everything, classifies everything according to the action IDs. And so you actually see every action ID when you select show standard. And so we notice here some are in black, some are in green. What seems to be the difference here is that the lines that are in green actually have no codes, no data associated with them, and so that indicator will always be the same there. Green meaning no codes associated with them. Okay, and then we have all of our action IDs here where the custom commands are essentially grouped together, or all the way at the top here you have your typical action IDs, power on, power off toggle, and it just depends on what type of product you're working with, how many action IDs will be applicable to the code set of each product. Deselect that now. Terminate with. This is a fantastic way to automatically add carriage returns or line feeds. Opening up this menu here, you can see you could add just a carriage return to the product if you'd like, to the code set. Just a line feed, or carriage return then line feed, or line feed then carriage return. Now we use the typical values of carriage returns in line feeds, which are typically a backslash and then a lowercase r for a carriage return, backslash and a lowercase n for line feed. There are a few control systems out there that may do that in their own way, though. And by applying it and selecting the box here, we know that the carriage return, for example, gets added to each and every command for the device. Now, not all devices require carriage returns or line feeds, but even if it's not needed, I don't think there's any harm in sending a carriage return and a line feed. In fact, it could even serve as an advantage to you, because there are some devices out there that will not clean their buffer out, meaning if there's some garbage noise in the buffer for the RS-232 device, having that carriage return, for example, and line feed could help clean that out, so as to make sure that your next command you plan to send to the device is received as it should, instead of being perhaps lost in garbage that's stored in the buffer. You choose your language that we are speaking and controlling the devices with. Okay, you can edit functions. Okay, we could edit the code set, the command. We can add functions, add new functions. Okay, we could delete functions that are added or part of the code set. We could duplicate functions. Okay, now we have +1 brightness, copy 1. Let's go ahead and delete that. And of course, we could test functions as well. And since I do not have a visualizer with me here, let's go ahead and use this as an opportunity to access the Key Digital supplied library by opening, save changes, none. By default, as we described earlier, all the Compass Control software items are located in the C drive. Program files or program files x86 if you're running a 64-bit computer system. Key Digital, Compass Control, and now we're able to go into our library where we have the RS-232 database. I currently have a Key Digital unit connected here in my lab. So let's go ahead and open up the Key Digital library. And we have all sorts of different categories of products here. Let's see. We can open or expand respective categories by selecting that category and performing the action. Currently, our Key Digital library is filled with HDMI switchers, audio switchers, processor, IR routers, RS-232 routers, because essentially our products nowadays are routers, are matrix switchers for IR and RS-232 control, where just like a typical AV matrix switch, we're able to specify a destination and a source for any IR or RS-232 incoming signal. Video switchers, so these are more of your typical non-HDMI products, and AV switchers. We can see here that as I open up, let's go over to our HDMS 8x8, which is the device that I have connected here in the lab. So we could take a look at the classification of the switcher, this HDMS 8x8, a 8 input, 8 output switcher. And let's say, for example, if our code set required that we add an extra output, simply by taking that cell and adding the appropriate number of outs, adds the respective output to the system. And you know from our IR discussion in C2.2, we were able to just essentially take the commands from output 1. Now you see here though that the commands are still we have here that this is input 1, output 9, but the command stays the same. So we are truly cloning what was there for output 9. However, for output 1. However, it sure does save a whole lot of work that we're able to just go in and edit each function to make it output 9, for example, here. And go ahead and apply. And we would do that one at a time, but again, saves us a whole lot of work. And let's say here that I don't need that output 9 after all, because a 8x9 configuration is not possible with that product. We'd just go ahead and return this to output 8. There we go. Now, let's go ahead and work in our own database. Now, you may recall from the IR manager, we are able to open up and create our own database. So let's go ahead and do that here, where, for example, I'd like to actually take this file, the Key Digital RS library, and make it my own. How do we do that? Well, we can close our RS-232 manager. Let's not apply any saves here. We will go into our program files, where we are able to go to the Key Digital folder again, Compass Control. We have the library, RS-232 database, and I could simply go to the RS-232 library, copy that, and let's go into a separate folder now where I'd like to store my own RS-232 file library. And here we have my own library. I already have some key digitals in there just as a means of experimenting. But let's say that let's paste it in here. There we are. And maybe we'll call this, so as not to confuse ourselves here, Key Digital 3. Okay. JF, there we go. And now we have that in our own library so that I can enter my RS-232 manager again, provide the proper access, and where right now I'm pulling from the Compass Control folder on the program files, I can go into my own manager located in my documents, as you saw me place this in my own folder. This was Key Digital 3. It is now opening, and you see it's an exact duplicate of what we had there. So let's say, for example, that the HDMS 8x8 is a discontinued part, for example, and maybe there's just a number of devices in here that we're not really planning to use. So, for example, we have some older pieces in here, or it's just some parts that we're not going to be using. So we can delete any item here. In order to do that, you do it here in the Library Explorer at the X here, is where you could delete any components of the respective library. If we were to do it up in the top here, we could delete the entire item or just something off the clipboard. So it just depends all at where you're located. So we could go ahead and continue to delete some devices here that maybe aren't going to be of use for us. let's see, for example, maybe I don't need this entire category, the AV switcher, because those are analog products, and perhaps I'm a installer working strictly in the digital world. And I can remove my HDMSW 4x4, as that part there has now been renamed the KD 4x4XC. And we see we have that already cloned essentially for our library here. So now, for example, we could go in, and since this is our own library, our user library, we could even test a few commands before we move forward with perhaps creating new commands based on an existing product, or even creating new commands from scratch. And so the testing is actually very good, very nice interface we have here, where we could test any command and actually have the feedback shown in the terminal window. So remember, we're in command mode, which allows us to test, or switching over to terminal mode is where we are able to manually enter the commands here to be sent through the KD terminal. So let's go ahead and test a command. We're in the common all outputs right now. Let's see here. For example, we could do an all output to select input 1. Let's do that, highlight that one, and just hitting the test function here. There we go. And physically in front of me, I do have the response on my HDMS 8x8. And you see, actually, this is verbatim the feedback that comes from the HDMS 8x8 unit. So it's a full bidirectional communication we have here. Let's see, output 3, for example, mute audio and video, test function. There we go, AV mute is on, and I do have that also reflected on the LED screen of my product. Let's toggle that now, test. There we go. And on my screen it says off, yet on my KD terminal window it says toggle, but it does give us the status on the actual matrix unit itself. So you see, it's a very nice window for testing commands. And let's say, for example, that I wanted to switch over into terminal mode so that I can manually enter my commands. We could go ahead here, and let's just say we want unit status. Now, keep in mind here, you do need to send the appropriate carriage return or line feed, okay? So, send command. Command send failed. Connect. There we are. Don't forget to connect in your terminal mode here. We're connecting to our actual device, and you see it's a lengthy feedback that we've just asked for, but this was the entire unit status of the KD HDMS 8x8. And now say, for example, you yourself have the HDMS 8x8, as I do here, but you know that it is transitioned to the HD 8x8 BT. You can actually test codes. We could go in and now test some codes for the HD 8x8 BT to ensure that they're going to work just fine with the HDMS 8x8 and vice versa. After all, at Key Digital we have essentially made our RS-232 commands very uniform at this point. So let's go ahead and test the power off. There you go. We even got a response from our 8x8. So we know that these commands are also working for your HD MS 8x8, even though they are the HD 8x8 BT commands. Okay. So let's go ahead here now and create a brand new product from scratch. Let's say that there is a new HDMI matrix switch, or let's just say, for example, that it is the HDMS 8x8 and that it was actually something we had to create here. HDMS 8x8, we'll add a suffix to the model number so as to not make a duplicate of the part that's already in there, that is the HDMS 8x8. Alright, so now we are in we have here the model added to the library. We could set up the switcher, classify it as a matrix switcher. Let's say it's an 8x8 configuration. We could set the settings now because previously I was already at 57,600, but you could see our range here from 1200 all the way up to 115,200. 8, none, 1, flow control, none. Okay. Let's go ahead here and automatically apply the carriage return and line feed termination, since we have an opportunity to do that, and it could save us a few keystrokes with each command. We're not going to apply any repeats here. We are already connected to our MC2500 here, and we'll be testing out of port number 1. So the common all commands, again, that's where you typically have your power on, power off. So let's go ahead and make that. That one is a, we'll apply its name, power on. It's a very simple command. I know it as PN. And let's go ahead and add our power off. Power off. Name it whatever we'd like it to be named. Just the action ID is from the drop down there. Now PF. So you notice here we're working with some commands that are slightly different from the others because, again, the other commands had manually we had entered the carriage return and line feed, and that's when we told our engineers, hey, we'd really like to have that automatically terminated with the option there of a drop down menu. And that's when they added it after we had already created some of the database for the key digital parts. But we could go ahead and test these now, and you'll see that they don't have, or we'll see how they work without the carriage return and line feed manually entered. So let's clear our window out here, and let's switch back on over to command mode. And we will go ahead and test the function. There we are. Power already on, so that's our feedback we received from it. Let's go ahead and test again. There we are, power off. So let's go ahead now and make some output switching commands, for example, and show you how easy it is to duplicate those commands to all the way to your 8 outputs or however many outputs you may have. So of course we need to select a row here, add a function, assign a proper action ID. For example, input 1 switching command. Let's see, here it is. Input 1. You see it immediately adds it as red, meaning it is a brand new command that's not saved, doesn't have any data yet. Okay. Function name, we will call it input. Actually, let's call it output 1. Input 1. Function data. This is where we go ahead and add our command. And we will use SPO 01 SI01, and this is a pretty standard switching command for us, video and audio switching together. SP is a standard prefix of our commands, O as in output 01, SI as in select input 01. Parameters is used when you have commands with variables or perhaps bidirectional functionality required with them. We don't have any number of parameters for this one. And then we'll leave our repeat and delay settings as default, which again, we have not had any of them applied here. So now we have that command entered, and we could go ahead and test that command. Let's see. Oh, it is powered off, it tells us. Hey, that's great. It lets you know. Let's see. That of course it can't switch when the power is off. Power on. Okay, we have our command back on here. Output 1, let's see. Output 1, input 1, let's test that. There we are. We received our feedback. And now what we can do is go ahead and output 2, we could clone output 1 information there. Output 3, clone. Output 4, clone. Output 5, clone. Output 6, clone. Output 7, clone. Output 8, clone. And we just simply go in and begin editing these. Let's start with output 2, of course. We can edit the function name. I had called them output comma, input number. The command here would actually be output 2, select input 0, 1. Let's see, let's do this the quick and lazy way, if you will, where we'll copy this. That's output 3, and make the appropriate changes to our actual command as well. Output 4. Output 5. Select input 1. Repeat for 6. Seven. And finally 8. Output 8, select input 1. Okay, let's give it a save here. And we do all of this here because it's obviously a good idea to test all of your codes before you go ahead and make a whole code set, if you will. So let's go ahead and give it a test. Output 2, video 1. There we are. Output 2, video set to input 1. And oh, looks like I've changed my response time there as I was playing around with my system here. So you saw that it took maybe 2 seconds actually before you received the response. Let's see how that is adjusted now as we test output 3, input 1, test. Output 3, input 1, there we go. Output 4, input 1. Give it a test. There we are. Output 5, input 1. Very good. And now, as we conclude our testing, we could essentially go into your output 1 here and add any and all codes you'd like to apply for each of your outputs, assign the appropriate action ID, function name, etc., etc., and go ahead and then clone that output 1 across the board to all 8 of your outputs. And you could test all the codes. Or really, once you test them all under the output 1, you could assume, of course it's always a good idea to test, that it's going to work just fine if they are verified for output 1, as we've simply just cloned them. But you do want to make sure, of course, that your response is correct, that our output 1, let's see here, output 6, for example, as we look at our code here, my output 7 selection, I left the code set as 0, 1, so that's a good thing as I caught it there. So I'm going to leave all of this in the video for you guys to see just how useful this this bidirectional terminal built into the software really is. And now it looks like everything is correct, and some of you guys may have caught that as I was doing it. So let's give a test function for output 7, select input 1. And it looks very good. So save that.